Okay, so this video is the first episode in a series on practicing programming. Every week, presumably this will be the test, we're going to take a task in programming. Presumably this will be the case. We're going to take a task in programming, and this task in programming is simply going to take some sort of function and it's going to spell it out in a form of practice. It's just a way to show what I'm doing that week to practice. As such, we can look at this function this week in which I have written for the situation. What's the situation, you ask? Well, let's have a look. I've discovered this, the online encyclopedia of integer sequences, which you'll probably be seeing quite a lot during this series, and I sort of use this to practice. This week, I decided to make an algorithm that emulates the length of the binary representation of n on a graph. What's interesting about this is particularly how many different ways you can create this. Now, I've only finished one algorithm here. However, I have created two, despite the fact I haven't finished the second one. I will show it, but I will show what I have of it. It's the skeleton of a structure. And honestly, all I need to do is just figure a positive way to perform the manipulations to calculate binary from a decimal. And yes, I do know how to do that. It's just it's just thinking about an algorithm to do it, and within the specific language that is Julia. And this whole series, that's not going to be language specific. Next week I'd plan on doing it in C, but Julia is just what I wanted to do it in this week. Now, what's interesting about this sequence in particular as well, as I said, is just the many ways you can do it. And the reason there's many ways to do it is simply because of how repetitive this sequence is. Here you can see a list, which by the way, you can find by clicking this link here, list under the length. But yeah, here you have a simple list. You realize how the pattern this follows, right? Notice how this doubles every time. And now it also follows the pattern on this side too, but in a different way. I'll start on this side. So here the length doubles. So you have 1, 2 here. Then you have 1, 2, 3, 4. And then you have 1, 2, 3, 4, 5, 6, 7, 8, and so on. Pretty cool, right? We can use this in an algorithm, which is what I've done for the first one. Of course, this also aligns right where the binary changes as necessary. So if we have a look here, this also doubles. So this changes at 2, this changes at 4, this changes at 8, this changes at 16, they both double. So you could use either one either way. Following this method, I have used it here. I've used it here by using the length to notate this doubling over here. The mod is what is actually modified and going into the array. Of course, we're using an if statement to compare the I to the length. The I is out of max nums, which is presented through this parse statement and a read line. Now, the read line takes in the notation here from this console, and the parse converts the string to an integer, which I've specified here as an unsigned integer 64. Now, of course, we can run this, so it'll take a second to kick up. and we can continue discussing this. Here I have used plots to show the plot whenever this boots up. Julia takes a little bit, and my CPU can be a little slow. Here I'm going to set it to 1000 just to quicken things up. Steam mode. That should be done. Yep, very quick. We'll open up the plot. As you see, it works as intended. Of course, I have attached some extraneous features to this as well. First off, you may not have noticed, although you may have, that this has a parentheses here, and another parentheses here. That may not make sense to you, although it likely does if you're an experienced programmer. By the way, here's the plot. Looks pretty cool. Now, looking at this, again, you may or may not be confused about this. What that is an instantaneously invoked function expression, or IIFE. Typically, you see this in JavaScript. You don't really see this in Julia. It may be possible in Python. I'm not sure about it. Do not take my word on that. But I do know it is possible in Julia and JavaScript. And the reason being is both functions use first-class functions, which allow you to use IIFE as such. You may be wondering what this is. This here is actually a special macro that Julia has, which allows you to separate anything in a for loop. And this is pretty cool if you ask me. I think this is awesome. It allows you to separate anything in a for loop to a multi-threaded function. So essentially, it takes these iterations of array here, and it divides them into separate threads, which is pretty cool and efficient if you ask me. I could probably test this and remove the threads, but I don't have my IDE picked up right now. Yeah, a little unplanned, but essentially that's the entire algorithm. Looking at the graph here, the classic big O complexity chart, I would say this follows about O, N. So I'd say it's a fair function. And people could criticize me. If you have a better way to do this, go ahead and tell me. I am willing to learn. As promised, I can show you the second function now, which obviously isn't finished and is a little messy because it's unfinished. Perhaps I'll have this finished by next week. I don't think I will, but nonetheless. Of course, here you enter the binary length. It parses, which is reading from a string to an integer. Here it takes the binary lengths. It takes the binary lengths, divides it into two halves, and it attempts to take. Here it takes the binary length and divides it into two halves. It then calculates the integers to iterate with. Here's the initialization of the arrays. And here's a while loop attempting to iterate from the top of the function and the bottom of the function simultaneously, so they return to the middle. Of course, I believe this would be a worse function. Thinking about it, of course, you can see that here I was attempting to find a way to change into the binary. I was hoping that Julia had a more efficient function for it, but it doesn't seem like it. I will probably have to make my own. Looking at this function, I would expect this to, of course, this increases. It doesn't really increase in complexity. I would say it's. I guess it would depend on the binary function. That would make sense for it to depend on the binary function. So, rating that one I would say it's about maybe it's either ON or ON login. I wouldn't expect it to be any more than either of those two. Yeah, someone could probably correct me with that one, but this one I could see being less efficient simply because of the way it's managed. If I provided a better way for it to manage the different sections with different sizes, but then again, that would also increase in complexity, and increasing in complexity, but then again, that also increase in complexity, which presents the same problem. And if I increased it in complexity that way, it would probably end up here. So, take it as you will, it's probably better just to stick to the simpler function, such as this, Occam's razor. Well, I think that's a pretty good end to the video. So, I have, Patreon, Ko-Fi if you want to donate. Of course, I have socials. I have Twitter, Discord, and of course the GitHub. If you want to follow me there, subscribe, of course. Thanks for watching.